Okay, my dear children. Now, in the earlier chapters, we discussed several things related with the chemical changes, physical changes, then about the combustion process, right? So, in this chapter, we'll be discussing about flames, right? Related to candle and a Bunsen, right? So, first of all, you are given with a candle flame, right? So, candle flame, and here we are discussing about the areas related to a candle flame and what kind of things contained on those, so on those types of areas, right? So, my dear children, you are given with a figure. In this figure, you can observe the areas related to a candle flame. So, first of all, you can observe a barely visible outer zone, barely visible, very lightly visible, right? Barely means here you have to look it very carefully and closely when you are observing this barely visible outer zone. And at that zone, at the bottom, you can observe a blue color zone, right? A blue color zone. And there is a non-luminous zone. Non-luminous means we can't see it, right? We can't clearly observe it, a non-luminous zone. Then there is a yellow color luminous zone. So these are the four main components or four main types or four main key areas that can observe within a candle flame, right? So let's see what are the special points in each of these areas. When a candle, first of all, let's see how does a candle flame is going to occur. So, when a candle is lit, solid wax turns into liquid wax. So, when I'm going to light up this candle, this solid wax contained here is going to convert into liquid wax, and it is going to travel through the wicks, right? Solid wax turns into liquid wax. Liquid wax moves up through the wick and it's going to vaporize. So it's going to travel through the wick and it's going to vaporize, right? It's going to vaporize. This wax vapor, so you know that solid wax is going to come out through the wick and it's going to vaporize, no? So that vaporized wax is going to react or interact with oxygen and oxygen gas, right? And to produce heat and light, giving rise to the flame of the candle. So the candle wax which is coming from here, it's going to vaporize with the presence of suitable ignition temperature, and it's going to interact with oxygen to produce this wonderful flame. Okay, so this is how the candle flame is going to occur. So, observe the candle flame in here, in the figure. It has three clearly visible zones. There are three zones, and out of the three zones, this blue color area is contained within one zone. Okay, you can observe it clearly in the figure also. The outer zone, the bottom part is the blue zone, right? So, my dear children, let's head on to the lab. Okay, and we'll observe the candle flame and we'll identify these areas. Then once again we'll come back and we'll identify or we'll discuss special things related with the candle flame. Right, my dear children, now we are about to discuss the areas of a candle. So if you take a candle flame contains several areas, right? So within this activity, we'll be discussing those areas, how to identify those areas in a candle flame. Right, now, I have a candle, a lighted candle with me, right? So let's identify the areas in this candle. So here, if you take the area around here, right, this area, it's barely visible actually. you can't clearly observe this area which I am pointing. Like a shadow. It's like a shadow. Like a small bit of a shadow is getting emitted from that area. Right? It's very barely visible to us. Okay, so that zone is referred as the outer zone of the candle flame. Outer zone. So, this area after the outer zone, this area here, you can observe that area which I am pointing in here. This area has a bright color, bright yellow color, this area. So, that area is referred as the luminous zone of the candle flame. The luminous zone. Then after that, below the luminous zone, like when you come up to here, this area, within this area, there is a flame, but we can't observe it very clearly. Actually, it has become invisible and it has become transparent too. Transparent means invisible here. You can directly see the black color surface in here to this area, in here, this area, right? You can't observe a flame, but the flame is there. Actually, you can't observe it. It's because that area is invisible to us. The invisible zone. So finally, at the bottom, you can observe the blue color range. Here, you can observe a blue color range in the candle flame. So candle flame, in a candle flame, these are the main types of areas which we can observe in a candle flame. Right? So my dear children, when we are discussing further things related with the candle flame, right, you will be observing, or you will get to know what are the contents of each in these areas, right? So we'll head on to the classroom and let's see what kind of things or what sort of things are contained within the each area of the candle flame. Right, my dear children, so we observed the candle flame and we identified the areas and the key factors, key points related with the candle flame. So let's see what are the things contained in each of these parts. So first of all, the inner zone is the non-luminous zone, right? So here the first and foremost zone, this zone is called as the non-luminous zone. Non-luminous, right? It contains wax vapor. It contains wax vapor. So this is the area which contains wax vapor, right? Non-luminous zone. Its temperature is low relatively to that of the other zones. So relative to the other zones, it has some amount of low temperature, right? So the first zone is called the non-luminous zone, has a less amount of temperature and it contains wax vapor, right? Outer to the non-luminous zone, is the luminous zone, right? The yellow color luminous zone can be observed at the next, okay? So here you can observe unburnt carbon particles. That's why it is having a yellow color, right? When we are studying about the complete combustion and incomplete combustion, my dear children, I think you got a knowledge about what is the color during complete combustion and what is the color during incomplete combustion. So during incomplete combustion, I told you a yellow color flame is going to emit, and during that complete combustion, see, like in here, a blue color flame is going to emit. So as there is incomplete combustion at the luminous zone, we can observe unburned carbon particles, right? There are unburned carbon particles, right? So outer to the non-luminous zone is the luminous zone. Unburned carbon particles present in that zone, it's becoming incandescent, okay? the unburned carbon particles present within that system or present within that unit is becoming incandescent, right? And it becomes incandescent, emitting a yellow light. So the unburned carbon particles, which is becoming incandescent, is the reason for having that yellow color flame at the luminous zone, right? Okay. The temperature in this zone is greater than that of the non-luminous zone. So if you check the temperature in this yellow color zone, right, temperature is somewhat greater than the non-luminous zone. Incomplete combustion is going to happen. It's incandescent. Okay. The yellow color is occurring due to that unburned carbon particles due to the incomplete combustion. Right. Then outer to the luminous zone, there is another zone which appears in blue color, right? The final zone. Base is in blue color, the outer zone, right? So outer to the luminous zone, there is another zone which appears in blue color at the base of the flame. But it is hardly visible in other areas. Now, base is in blue color, but if you check the other areas, right? If you check the other areas, the base is in blue color. We can clearly observe it. I think you have observed it very clearly when we are observing the candle flame at our laboratory also. Base can be clearly identified with the blue color. But the thing is, when you check the outer areas, which is arising from this blue base, those areas are hardly visible, right? So, outer to the luminous zone, there is another zone which appears in blue color at the base of the flame. But it is hardly visible in other areas. In other areas, it is hardly visible. And this is known as the outer zone. So, this final area is referred as the outer zone, my dear children. So, it is also called as the invisible zone. And it has the highest temperature. So, invisible zone or the outer zone has the highest temperature out of these areas. That's why the base of that barely visible zone or invisible zone is in blue color. A complete combustion is going to occur. So during that complete combustion, large amount of heat energy is produced. So that's why it has the highest temperature. So these are the main areas in a candle flame. And this is how a candle flame is going to be created, right? So we can observe three main areas, and within these three main areas, there is one sort of another area which is referred as the blue zone, right? So the three areas are outer zone, which is barely visible to our eyes, but the base is very visible, which is in blue color. Then the second zone is the luminous zone. It's becoming incandescent due to having unburned carbon particles, right? Then finally the non-luminous zone, which contains wax vapor, right? So if you compare the temperature, outer zone has the highest temperature, then luminous zone has the middle, right? Middle means greater than the non-luminous zone but less than the outer zone. The lowest temperature could be observed inside the non-luminous zone, right? Non-luminous zone. So these are the key factors regarding a candle flame. Right then. So in the next part, we'll be observing, right? We'll be observing about the Bunsen flame, my dear children. Okay, the Bunsen flame. So Bunsen flame is like this. This is the Bunsen burner. So in a Bunsen burner, there is a collar and there is an air pour. We can rotate this collar with that air pour to control the amount of oxygen gas which is getting entered to the system, right? So by turning this air pore here and there, we can control the amount of oxygen coming inside to the Bunsen burner. So by that way, we can control the amount of flame, right? Height of the flame given out by the Bunsen burner. And this is the gas tube. We have to connect it with the LP gas container. Then this is the foot. It helps to keep the Bunsen burner rigid. Then the stem of the Bunsen burner. Then finally the flame. Okay. So let's see what are the key contents and the areas related to a Bunsen flame. So the color of the Bunsen flame changes with the amount of oxygen gas supplied for the combustion. So I told you that according to the amount of oxygen gas that you are going to supply, the color of the Bunsen flame is going to change. Okay, right? So we can change the amount of oxygen by controlling this color with that air, which contains the air pore. Okay, so when oxygen supply decreases, when less amount of oxygen is going to supply into the system, the flame turns to yellow color. Why it is turning into yellow color? Due to incomplete combustion of the fuel, right? We need to provide good amount of oxygen. Adequate amount of oxygen should be provided in order to get a complete combustion. If there is no adequate amount of oxygen, then in that process we can observe incomplete combustion. So during incomplete combustion, a yellow color flame is going to emit. So when oxygen supply decreases, the flame turns to yellow. And when the flame receives enough oxygen, when there is enough oxygen, it turns to blue color, right? When there is enough oxygen in the system, the flame is going to turn to blue color, right? So in this figure, you can observe that blue color flame, right? So it is given here. I'll take the slide somewhat up. Okay, so by observing the blue flame well, so first of all, we need to adjust this thing into a blue flame to get a blue flame, right? And to have a complete combustion. So by observing the blue flame well, several zones of it can be identified. So by observing this blue color flame, we can observe several zones. So let's head on to the lab, my dear children. We'll observe the Bunsen flame. We'll identify the colors and the areas related to a Bunsen flame. And we'll come back once again to discuss the key points. Right, my dear children. Now, then in this activity, we'll be identifying several zones related to a Bunsen flame. So I have a Bunsen burner with me right now. So if you take a Bunsen burner, we can identify these areas, right, or these parts in a Bunsen burner. This base, it helps to fix the Bunsen burner on a tabletop like this, or on a surface to keep the Bunsen burner rigid. We can use this base. So base can be used to keep the Bunsen burner rigid. And after the base, you can observe there is a collar. This collar can be turned here and there. So when turning the collar here and there like this, you can turn it like here and there like this. See? You can observe the change of color in the Bunsen flame. It's because that there is an air pore like in here. So it allows to flow oxygen gas into the Bunsen burner. So you know that to burn any kind of a fuel, we need oxygen. So this is the entrance where oxygen gas is getting entered to the Bunsen burner, right? And you can observe the stem of the Bunsen burner next, right? This is the stem, and with after the stem you can observe the end of the Bunsen burner. So this is the gas tube which is being connected to LP gas supply. The LP gas coming out from the tube will get burned within the stem like this. So now let's identify the zones in a Bunsen flame. So I'll keep a black color board so that you can clearly observe. Now let's observe what are the areas or what are the zones that we can identify in a Bunsen flame, right? So first of all, if you observe this area, which is the most outer layer. So most outer layer in the Bunsen flame, you can observe the invisible zone, right? Unlike the candle flame, the Bunsen flame has like 99%, up to 99% a blue color, right? Here you can observe like small bit of a yellow color at the end of the Bunsen flame, but most of the areas are in blue color, right? So at the outermost area or outermost zone, you can observe the invisible zone, Then the zone after it, the second zone, like in here, right, you can observe the light blue area. It's somewhat light blue. If you compare the colors between here and here, this area and this area, right? So here you can observe some kind of a dark blue color, and here you can observe a light blue color. So these two zones are the light blue zone and the dark blue zone, right? So like in the candle flame also, here we can observe an invisible zone or else a non-luminous zone. Then after this light blue area and the darker blue area, in between those two, like in here, you can observe the non-luminous zone. It's not luminous to us. Actually, like it's invisible. Sort of an invisible area can be observed in here, right, in this area. So that is the non-luminous zone. So once again, we'll memorize what are the zones. So in the outermost area, you can observe the invisible zone. Then after that, the light blue zone, the dark blue zone. In the middle, in here, you can observe the non-luminous zone. So in a Bunsen flame, we can observe these four areas or these four zones very clearly, right? So we'll head on to the classroom and we'll observe what kind of things are contained in each of these zones. Right, my dear children, so we have observed the Bunsen flame, right? And we studied about the key components contained in the Bunsen flame. So let's see what are the things or how does these areas are going to create. So first of all, at the center of it is the non-luminous zone consisting unburnt gas. So at the center here, you can observe the non-luminous zone, right? Non-luminous zone. Right, here you can observe the non-luminous zone at the center. So it contains unburned gas. Okay, so non-luminous zone consisting unburned gas. Outer to the non-luminous zone lies a dark blue zone and a light blue zone respectively. So you can observe here dark blue zone, light blue zone, right? The dark blue zone and the light blue zone. The outer part is the invisible zone. In the invisible zone, complete combustion occurs. Like in the candle flame, at the outer region, there is the invisible zone. At the invisible zone, you can observe the complete combustion of the gas particles, right? So these are the areas that we can observe in a Bunsen flame. First of all, the non-luminous zone located at the middle, then the dark blue and the light blue zones respectively, then finally the invisible zone that has the highest temperature that undergoes in the complete combustion. So these flames are really simple, my dear children, right? Candle flame and the Bunsen flame. So let's move on with the next thing to study about further things related with our lesson. Right, now in this part we'll be discussing some special kind of a chemical change, some special kind of a chemical reaction. So this reaction is, my dear children, the tarnishing of metals. Tarnishing of metals. So let's see what does this tarnishing means, right? You have learned that having a shiny surface is a property of metals. This is also called as the metallic luster. Each and every metal has a unique lustrous nature. If you take the surface, it's going to shine out. When I'm going to take an iron nail and clean it very well by using sandpaper, right? It's showing a good luster. It has a wonderful lustrous nature. Even with the magnesium also, we can observe the same thing, but we have to clean it somewhat by using a piece of sandpaper, right? If you take gold, gold originally has this luster very well, and it's going to last for a longer time period as well. So metals have unique lustrous nature, okay? Each and every metal has this lustrous nature, right? This is called the shiny surface, okay? The lustrous nature is also called as the shiny surface. So it's a special property, a physical property in metals, my dear children. When metals are exposed to air for a long time period, that luster disappears. Now you know that when you keep a piece of magnesium stripe exposed to air for a long time period, I told you in the earlier case also, the lustrous nature is going to disappear, okay? And if you take an iron nail and keep it in our environment for a long time period, once again the lustrous nature or the shiny surface of the iron nail is going to reduce, and a brownish color substance is going to cover up on the surface, right? You have observed these things. So my dear children, when you expose these metals for a long time period, right, to our atmosphere, the lustrous nature of these metals is going to disappear. The change in the surface of metals like this is called tarnishing. So disappearing of this lustrous nature, right? Disappearing of this lustrous nature and covering up the surface from an oxide layer or else a different kind of a substance is referred as tarnishing of metals. Tarnishing of metals. In simple, tarnishing means loosening the lustrous nature of metals, right? Why does the lustrous nature is going to disappear? Because some special kind of a substance is going to create on the surface, reducing that lustrous nature. Okay, right then. Almost every metal tarnishes, right? Each and every metal is going to tarnish. But the color of the tarnished substance is changed from metal to metal. If you take copper, brass, those metals are going to have a green color tarnished substance. Okay, a green color tarnished substance, copper and brass. If you check the surfaces, when time is going to pass by, a green color substance is going to cover the surface, and the shininess of the lustrous nature of the brass and copper will get reduced over time. If you take iron, steel, okay, if you take iron or steel, reddish brown color substance called iron rust, okay, reddish brown color substance called iron rust is going to cover up the surface. By that way, the lustrous nature is going to disappear. In aluminium, right, there's a special kind of a coating, not brownish color, right? It's like a silverly color. In magnesium also you can observe a silverly color, like ash color, a layer which is going to cover on the surface, right, to reduce the lustrous nature. So from metal to metal, the color of this tarnish, right, the tarnishing color is going to change. But however, ultimately what happens is the lustrous nature of the particular metal particle or particular metal is going to disappear with the time, right? So this reduction of luster or the shiny nature of metals is called as tarnishing of metals. Tarnishing of metals. A substance called rust. Substance called rust is formed on the surface of iron. Right? Iron. Tarnishing is for metals, especially for the tarnishing, the special kind of tarnishing that's going to happen within iron is called as rusting. So the material which is getting created during the tarnishing process of iron is called as iron rust. Iron rust. So iron is the most common metal that we used in our day-to-day activities. So therefore, right, iron is paying or iron is giving out more, right, pretty much more and good advantages to our day-to-day working activities. So my dear children, especially under the tarnishing of metals, we'll be discussing about the tarnishing of iron, which is specially called as rusting of iron, right? So my dear children, you are given the substance called rust is formed on the surface of iron due to tarnishing. So if iron is going to tarnish, we refer that thing as iron rust. Okay, iron rust, a special term. This is reddish brown in color. So this is reddish brown, right? Brownish color is okay. Reddish brown, brownish color. That's the color of iron rust. It is called the iron rust then. This process is called the rusting of iron. So making this reddish brown color substance on a certain metal, not actually a metal, on iron, my dear children, right? Specially called as rusting of iron. Rusting of iron. Tarnishing is common for all metals, especially for iron, very specially for iron. We refer that thing as rusting of iron. right? Rusting of iron. So the tarnishing process that occur in iron is referred as tarnishing. Okay, right? Tarnishing or rusting, right? The special kind of tarnishing that occur within iron is called as rusting. Okay, rusting of iron, right? So due to tarnishing and rusting, the surfaces of the metals corrode. Surfaces of the metals corrode. So therefore this is also called as corrosion of metals. Corrode means their physical state or that hardness, ductility, malleability, these special features are going to reduce. Okay, so that is called as the corrosion of metals. You know that iron is very hard, but if iron is going to catch up with iron rust, after some time that hardness is going to reduce. Okay, so this is called the corrosion of metals. So tarnishing of metals and rusting of iron. Tarnishing is for metals, rusting is for iron specially. Okay, so tarnishing of metals and rusting of iron are chemical changes, means that we can't revert it back. These changes are chemical changes, not physical changes, my dear children, right? So if rusting of iron is going to happen, if tarnishing of metals is going to happen, new substances are getting created. So these new substances cannot be reverted back into the same metal once again. Okay, so these tarnishing process are considered as chemical changes. Okay, so this is about the tarnishing of metals, my dear children. So we got a simple idea about tarnishing of metals and what do you mean by the tarnishing. And especially tarnishing of iron is referred as rusting. Okay, so the reddish brown color substance that's going to deposit on the iron surface is called as iron rust. Iron rust is the main reason for the tarnishing of iron or rusting of iron. Right then, so we'll move on with the next thing contained in our lesson. So we'll be mainly discussing about iron here, because iron is the most common metal that we come across in our day-to-day life. So my dear children, we'll be discussing about tarnishing of iron. You know that especially this tarnishing process of iron is called as rusting of iron, right? So we'll be discussing about rusting of iron under the tarnishing of metals part. Right then, so to investigate about the factors which are essential for the rusting process, you are given with an experiment and we'll conduct this activity. Now let's see what are the materials that we need when we are investigating about the factors necessary for the rusting of iron. So in order to check the rusting of iron process, definitely you will be needing some amount of iron. So to provide some amount of iron, you are given with iron nails, right? So we'll be needing clean iron nails. Okay, clean iron nails means these iron nails should be free from rust. Okay, so if you can't find these clean iron nails, you can get some iron nails and you can scratch it by using a piece of sandpaper, right? By that way also you can remove this iron rust if it has very less amount of rust, right? So this is the first material you will be needing. You will be needing very good and clean iron nails. Then we'll be needing some coconut oil. Coconut oil. Okay, clean iron nails, coconut oil. Then boiling tube. boiling tube. Right. So these are the materials that you need. You need a boiling tube, some clean iron nails, a coconut, some amount of coconut oil. And my dear children, now we have to insert these iron nails to the system over there. So it's wise to use a cork as well, a cork stopper. Okay, right. So let's see how to conduct this activity. So this is the way of conducting activity. Actually, the cork thing will be needed in our next experiment. Up to now, you won't be needing a cork, right? So we'll see how to conduct the experiment right now. So take some water into a test tube or else a boiling tube and heat to boiling. So we have to heat it. We have to take one boiling tube, insert some water, and we have to boil the water very well. Put a cleaned iron nail into it and cover the water surface with a layer of coconut oil, right? So here given, you can observe it, the setup A, right? The first setup, boiled water, you have to insert some iron nails and a layer of coconut oil. Okay, oil layer is placed to prevent the dissolving of air when water cools. You know that there are different types of air particles which is going to remain in our atmosphere. So when this system is going to cool down gradually, air particles are going to dissolve within the water. You know that oxygen is a substance or else a type of a gas that's getting dissolved within water. That's why the fishes can that's why the fishes can respire in water, because oxygen gas is getting dissolved in water. So when water is going to cool down after the boiling process, some amount of oxygen is going to dissolve in it. To avoid that thing, we have to add that layer of coconut oil. Right. Take equal volumes of cold water to two other test tubes. We have to take another 2 test tubes or boiling tubes, right? So we have to take 2 other test tubes or boiling tubes and put a cleaned iron nail into each, and we have to put clean iron nails into it. Put an oil layer to one of them. To one container we have to put an oil layer, right? So here you can observe the second setup, B setup, which is covered with an oil layer plus the water with clean iron nails. Leave the other test tube as it is, setup C, right? After few days, observe the setups. So you have to leave it for few days and we have to observe what's going to happen with the setup. So once again I'll explain. 3 boiling tubes, you will be needing 3 boiling tubes. Take the first one, add some water, boil the water very well, add clean iron nails, add a layer of coconut oil, name it as A. Take the second boiling tube, add just water into it, add some clean iron nails into it, add a good layer of coconut oil and mark it as B, the second setup. Take the third boiling tube, just add water, just put an iron nail, leave it in the same place, name it as C. Keep this setup for about few days and observe. So this is how to conduct our activity, my dear children, right? So let's head on to the lab. We'll conduct our activity and let's see what are the changes that's going to occur in each of these instances. Right, my dear children. Now in this activity, we'll be identifying the factors which are essential for the rusting of iron. especially in this activity, we'll be observing whether air is necessary for the rusting of iron, right? So I have these materials with me, so I'm going to conduct the activity. So let's see first of all what are these materials. So I have first of all a forceps to handle the boiling tubes, right? Then after that, several boiling tubes. Here I have 3 boiling tubes, 1, 2 and 3. Some water. Then this is coconut oil, right? Coconut oil. And some cleaned iron nails. Here you can observe there is no rust in these iron nails. Okay. I have 3 iron nails separately for each boiling tube. So these are very cleaned and there is no rust at all. See, you can observe it. These things are very clean and there is no rust at all. Right. And I have a spirit lamp here with me. So I'm using this spirit lamp to boil water. Okay. So let's see how to conduct the activity then. So first of all, I'm going to do is I'm going to insert 1 iron nail each like this for the 3 test tubes separately. Number 3. Right. Then I'm going to take some amount of water and just add this cool water. This is cool water, normal cool water, tap water. I'm going to insert this normal cool water into 1 test tube so that it covers entirely like this. So that the iron nail is getting covered entirely like this. Okay. So I'll place it in here. Number 1. Then I'm going to use the second test tube, this one. Once again, I'm going to put some amount of normal water like this. Then for this, I'll be inserting some amount of coconut oil, right? So I'll place the test tube like this and I am going to insert some amount of coconut oil into this solution, right? So here you can observe that after inserting coconut oil up to a certain limit, the coconut oil layer and the water layer is getting separated like this, right? Okay, now the number 3, third boiling tube. In the third boiling tube, there is an iron nail, you can see it. So I'm going to insert water to cover up the iron nail. Then I'm going to heat this boiling tube very well until the water boils. I'll keep this system somewhat away like this. I'm going to use my forceps then, and I'm going to take this boiling tube which contains normal water and I'm going to heat it down until water is going to boil, right? So what's the purpose of boiling water? Purpose of boiling water is that we need to expel all the gases which are dissolved already inside the normal water. You know that gases like oxygen, carbon dioxide are slightly getting dissolved inside water. So to expel all the gases contained in water, I am going to boil it very well. So you know that when you are boiling water, the gases which are already dissolved inside the water is going to evaporate. So let's boil water and evaporate all the gases inside the system. Right, so keep it in here. Let's light up the spirit lamp and we'll boil in tube until the water is going to boil and evaporate all the gases in it. So give it some time to boil water. It's important to boil the water very well to evaporate all the gases dissolved in it. So already you can see that the bubbles are getting formed inside water. Those bubbles are the air particles or gases which are already dissolved inside the water. So I'll use this black color surface. Here you can observe. See, the bubbles are right. Now it has boiled very well. So I'll remove it now. Now let's keep it for some amount of time. Now we'll add the coconut oil into it. Okay. A good layer of coconut oil. Right. So we used boiled water in this setup. Okay. And I have added coconut oil as well. So what's the purpose of adding coconut oil for these boiling tubes? You know that these test tubes or these boiling tubes are exposed to normal air. It's in our normal environment, no? And you already know that gases are going to dissolve within normal water. So if you take this boiling tube, it do not have any coconut oil layers. So here this one is exposed to the normal air in normal atmosphere. But this one, it's also been exposed to the normal atmosphere. But when you're adding coconut oil into it, right? When you're adding coconut oil into it, the gases which are at the atmosphere is not getting in contact with water at the bottom. So the gases or the atmospheric gases will not get dissolved inside the water, right? So it inhibits the dissolving of gases, atmospheric gases in normal water, right? So the purpose of adding coconut oil is to avoid the dissolving of gases within water. Right, now let's insert this thing into the test tube container, right, like this. So here you can see, if you take this one has the boiled water where we use the single stand, and this one, it contains cool water or normal water, right, in the other stand. Now we need to keep this setup for about 2 to 3 days to get our observations. So we'll keep this setup in a different place so that they would have some time to process. And after 2 to 3 days, we'll see what are our observations. Right, my dear children. Now I have kept this system for about several days. So now I am about to see what are the changes that occurred in each of the iron nail. So first of all, I am going to take the boiling tube that contains normal water. If you check this setup, you can see clearly the color of water has already got changed. Initially it had a color, it haven't got any kind of a color. It was colorless. Now it shows some amount of a yellow color, light yellow color. So let's see what has happened to the iron nail. So I'll put this solution into the Petri dish, and now I am going to take the iron nail out. So if you observe this iron nail, you can see iron nail has rust, and it has rusted very well. See, it has rust all around the surface, right? So it has rust very well, right? So I'll keep this iron nail by keeping it on the Petri dish so that you can observe very clearly. This is the first one, which contains normal water. Okay. Now I'm going to use the Petri dish, the boiling tube, which contains, now this is the boiling tube which contains normal water plus some amount of coconut oil, right? So I'm going to pour it down to this Petri dish once again to observe the color change. So in here, in this one, you can observe there is rust, but up to a certain limit, up to a certain extent, not that much rust. Okay, there is not that much rust rather than the previous one. It has rust, but up to a certain level only. We can't find rust all around the surface like the previous one. Okay, so I'll keep it in here. Then I'm going to use the third and the final boiling tube. So I'll remove this one. This was the 2 boiling tube which contains normal water, right? So this is the one which contains then the boiled water. So I'm going to take the Petri dish, third one, and insert this solution into it, and we'll see what has happened to the iron nail. So if you check this iron nail, you can see there is no rust at all. There is no rust at all, right? See, there is no rust, right? So I'm going to keep it over here. So I'll use a tissue paper, right, and place each of these iron nails so that you can observe it very clearly. Right. The first one, this one contained normal water. There is no coconut oil in it. So this is the first one that contained normal water, right? Check how the iron nail has rust. Normal water. Second one, normal water plus some amount of coconut oil. Normal water plus some amount of coconut oil, right? Number 3, the third and final one, boiled water plus coconut oil, right? So these are the 3 iron nails. So we'll compare the rust in it. Normal water only, it has got rust all around the surface. Normal water plus some amount of coconut oil. To avoid the contact of air particles, we add coconut oil. So coconut oil plus normal water. There is rust, but up to a certain limit, right? Not that much rust like this, but up to certain limit it has rust, right? Now the third one, the final one. Boiled water plus coconut oil. There is no rust at all. You can observe there is no rust at all. See? So, these are the observations from this experiment. Right? So, my dear children, let's head on to the classroom once again and we'll write down our observations which we took, and let's see what is the explanation for these kinds of observations. Right, my dear children, so we conducted the activity and you could observe the iron rust. Okay, you could observe the iron rust in the iron nails. But specialty in here is that in one particular setup, you can't observe iron rust. Okay, so the iron nails which was in the boiled water with a layer of coconut oil haven't got rust at all. Iron nails which is exposed to normal air without coconut oil, right, has plenty of iron rust. Iron nails which was inserted into normal water with a layer of coconut oil has very less amount of iron rust. Okay, so these were our observations, right? These were our observations. So we'll write down our observations one by one by naming the setups A, B and C. So in A is the one which we used boiled water plus coconut oil. Okay, A is the setup which we use boiled water with coconut oil. So in A, no rust. No rust in iron nails, right? No rust. In B, here we used cold water plus coconut oil. Cold water with coconut oil. So in B, right, less amount of iron rust. Right, so no rust in iron nails in A setup. In B setup, less amount of rust in iron nails. And in C, I'll erase the conclusion part. Right. So in C, here only cold water. That's the C or the third one, right? Third setup, more iron rust. Right? More iron rust is observed. Right, so this is our observation. In A, where we use boiled water and coconut oil, no rust. In setup B, where we use cold water with coconut oil, less amount of iron rust in iron nails, right? Then in the C, only cold water, more iron rust is observed. So these are our observations, my dear children. So I'll name those things as 1, 2 and 3. 3 observations from the 3 setups, right? What is the reason for this kind of a observation? So if you take the first setup, setup A, we used boiled water, means that there are no any gases dissolved in the water. By boiling, we are going to evaporate all the gases contained within the system. By adding coconut water, we are inhibiting the entrance of other gases to the system from the atmosphere, right? So gases are not going to dissolve, or air particles are not going to dissolve at all in a system. So there is no air in system A. So therefore, there is no rust in the iron nails. The second one, in B, when you are adding cold water, there is some amount of gases or air particles which is already dissolved in the water itself. Because we are not boiling the system, no. If you are going to boil it, then that gas is going to evaporate. But here we are just using normal water. So therefore, some amount of gases are contained at that water which we used for the second setup, or the setup B. So some amount of air is there. Due to that some amount of air particles, some amount of iron rust could be observed. In the third and final one, we use normal cold water. So there is plenty of air contained in the system. And we haven't inserted the coconut oil layer as well. So air particles can freely enter to the system from the atmosphere. So there is plenty of air in the third system. So due to having plenty of air particles, plenty of rust or more iron rust is observed in the third setup. So my dear children, from this experiment, from these particular observations, we can conclude finally air is necessary for rusting, right? Air is necessary for rusting. Air is the main factor which involves in rusting. Air is very important for rusting. That is our final conclusion from the activity. So we can conclude finally. I'll take the slide somewhat up to write down my conclusion. Right? So my conclusion is air is important for rusting of iron. This is the final conclusion that we can take from this experiment, right? Based on the above observations, we can conclude this thing. Air is necessary for, or air is important for rusting of iron, right? So my dear children, we studied the first factor necessary for the rusting process, that is air, right? So let's move on to examine the next experiment. Right, So before that, once again, the explanation is given here. So we'll see the explanation and we'll head on to the next experiment. So the iron nail in test tube A does not rust as it contains boiled water. All the air dissolved in it has been expelled, evaporated, right? Putting a layer of coconut oil on water has prevented the dissolving of air when water cools. So I have explained this thing earlier, right? When you add in coconut water, right, it avoids mixing external gases with the system. And when you are going to boil that water, the air particles contained in the system is also going to expel, right? Also going to evaporate. Second setup, or the test tube B, it contains cold water. So therefore its water contains air, right? Its water contains air. Because there is air dissolved in the water, iron nail is going to rust. Some amount of rust could be observed, not that much to a larger extent. Okay, some amount can be observed as there are less air particles within the system, and air particles are not getting entered the system because of that coconut oil layer. So there is some amount of air, therefore some amount of rust can be observed in setup B. Then the third setup, the nail in the setup C or test tube C is open to the outer environment. As it receives air from the outside, rusting occurs. Hence, it can be concluded that air is essential for the rusting process. So this is the explanation for our experiment, right? So I took that our conclusion as the air is very important for the process of rusting. So this is the explanation for that experiment. So we'll head on to see our next experiment in identifying the factors necessary for the rusting. Okay, we are going to study about the second factor. So the second factor will be needing these materials. Actually here we are going to show that moisture means water vapor is necessary for rusting, right? We're going to show that moisture or water vapor is necessary for the process of rusting. Okay, right. Now let's see what are the materials that we need. Once again, you'll be needing boiling tubes, clean iron nails, This is calcium chloride, okay, a chemical called calcium chloride. Calcium chloride can absorb water vapor, okay, or moisture. If you can't find calcium chloride, you can find silica gel. Silica gel also has an ability to absorb water vapor, right? So these are the materials you will be needing: boiling tubes, clean iron nails, calcium chloride or silica gel, right? So let's see the method, how to conduct the activity. So this is the method. Clean the 2 iron nails with sandpaper. If you are having clean iron nails, then you don't need to clean it once again. But it is better to scratch the surface to have a shiny surface, a good shiny surface, right? Fix them to the cork stopper as shown in the figure. So we have to get a cork stopper. In the earlier activity, I told you that when I'm going to fix the nails into the boiling tube, I'll be needing a cork stopper, right? So even though I haven't included that thing in the materials, cork stopper is also important in fixing these iron nails to the system, right? So a cork stopper, we need to insert a cork stopper into the boiling tube and we need to fix the iron nails like this. Okay. So when you are fixing iron nails, remember head should come down and the pointed area should also come down. And for the top part also, there should be head part and a pointed part. Okay. Right. Then we have to fix it like this. Then after that, add calcium chloride crystals to the boiling tube. We have to add these calcium chloride crystals to the boiling tube, or else that silica gel. Silica gel is also having an ability to absorb water vapor. Calcium chloride also has an ability to absorb water vapor. So we have to insert calcium chloride into the system, right, within the boiling tube. Make the tube airtight with wax or clay. So we have to apply some amount of wax or clay, right, on the top of this stopper in order to avoid the entry and exit of gases into the system or out of the system, right? Observe this setup after several days. Then after that we need to observe the setup. We have to keep it in a place for about 2 to 3 days. Then we have to observe what's going to happen here. Okay, then we have to observe the changes that's going to happen in the system. Right then, so my dear children, let's head on to the lab. We'll conduct the activity and let's see what kind of a change is going to occur within these iron nails when I'm going to conduct the activity. So let's head on to the lab and see what are the changes that's going to happen in these iron nails. Right, my dear children. So in this activity, we'll be investigating the next factor which is important for the rusting of iron, right? So here we'll be examining the necessity of water vapor or moisture for the rusting of iron. So first of all, I have a cork, and by using this sandpaper, first of all, I have stretched the surfaces of the iron nails very well and I have cleaned them. Okay, so you can observe there is no rust in it. So I'll remove the iron nail and I'll show it to you. There is no rust in these iron nails, right? So there is no rust. See, these are very cleaned. These iron nails are very clean. There is no rust at all. See, this one also, there is no rust at all. I have cleaned them very well by using the sandpaper with me. Right. So once again, I'll insert. Okay, so I'll keep it in here. Then I have with me a substance. This is called as calcium chloride. This is calcium chloride crystals. Specialty in calcium chloride is that calcium chloride can absorb water vapor in the atmosphere. Okay, so calcium chloride can absorb the water vapor in the atmosphere. So first of all, I'm going to use this calcium chloride and I'm going to insert this calcium chloride into our boiling tube. Right. So here we go then. I have inserted calcium chloride into the boiling tube. Then after that, what I'm going to do is I'm going to stopper it very well with this that has iron nails. See, cleaned iron nails. Okay, now I'm going to stopper it. using this cork. So I'll insert to here and I'm going to insert it very well like this. Okay children, now this is our setup. So inside the boiling tube there are some parts of iron nails, and outside the test tube also there are some parts of iron nails. Inside the test tube you can observe calcium chloride. So we'll keep it for some days. We have to keep the system for about 2 to 3 days. And after 2 to 3 days, we'll observe what has happened to iron nails. So we'll leave it like this, and after 2 or 3 days, we'll observe what has happened with the iron nails then. Right, my dear children, so I kept this system for about 5 days, right? Then here is my system right now. Okay, observe the system very clearly and check what has happened to the iron nails. You can observe clearly the top part has some amount of rust, right? The top part of the iron nail, which is getting contacted with the normal atmosphere, it has some amount of rust. If you check the part which is below means which is inside the boiling tube, in this part there is no rust at all, right? There is no rust at all, right? You can see it very clearly. These parts, the topper parts contain rust, but the below parts, which is inside the boiling tube, these areas do not contain any rust. These areas do not contain any rust, but these areas contain rust. Reason for this is, you know that, and I told you earlier also, calcium chloride can absorb water vapor. Calcium chloride can absorb water vapor or moisture. So when I'm going to insert the stopper, some amount of water vapor is getting trapped inside the boiling tube. So that water vapor is getting absorbed by calcium chloride. So inside the boiling tube there is no water vapor at all, right? But when you take outside, in outside there is normal, if you take outside this part, there is normal air in outside. In normal air or in atmospheric air, you know that there are some amount of water vapor. So these areas are getting contact with water vapor rapidly. But the area below or area which is inside the boiling tube do not get in contact with water vapor, right? The part of the iron nail which is located below the boiling tube do not get in contact with water vapor, because all the water vapor inside the boiling tube has already got absorbed by calcium chloride crystals. See, in here you can observe calcium chloride crystals. So calcium chloride crystals can absorb all the water vapor inside the boiling tube. So within this activity, or when conducting this activity, it's obvious to us that water vapor is really important for the process of rusting. If there was water vapor inside the boiling tube as well, then in that kind of a case, the inside part also will contain some amount of rust. But here, the inside part do not contain any rust. Means that water vapor is really necessary for the process of rusting. But when you compare the outside part means the area which is exposed to the normal atmospheric conditions. In normal atmosphere, there is plenty of water vapor. So this area is getting contacted with water vapor rapidly. So these areas or these iron nails will get rust very quickly as they have plenty of water vapor. So this concludes that water vapor is really important for the rusting process. Right, my dear children, so we conducted the activity and you could observe in some areas there is iron rust and in some areas we can't observe iron rust. So I'll show you in which areas could we observe that iron rust thing by drawing out a figure. So this was our setup. Okay, within this system there was calcium chloride. So in these areas means in the top part, right? In this top part you can observe iron rust, and in the bottom part, right, in the bottom part there is no iron rust. In this part there is no iron rust, right? In the blue color area you could observe iron rust, but in the black color area you can't observe iron rust, right? So we'll write down the observation then. No iron rust. No iron rust, right? Mark the cork. Okay. Then in here, the blue color area, iron rust can be observed. Right? So this is the observation that we can take from the experiment, right? You could also see this thing. So the top part of the iron nail, it has coated up with rust, and the bottom part, which is located inside the test tube or the boiling tube, it doesn't carry rust. So my dear children, the explanation for this thing is calcium chloride. I told you that calcium chloride or silica gel has an ability. Calcium chloride is not silica gel. Silica gel is a type of a chemical that can absorb water vapor. Calcium chloride is also a type of a chemical that can absorb water vapor. So calcium chloride that we used here has an ability to absorb water vapor from the system in here. So water vapor or the moisture is getting absorbed by the calcium chloride. So there are no water vapor within this system. Therefore, there is no iron rust. But the top part, it is being exposed with the atmosphere. Atmosphere contains water vapor. So therefore, the top part is going to receive moisture or water vapor very well. So therefore, within that part, we can observe iron rust. Okay. So the below part, no iron rust because there is no water vapor or moisture. In the top part, you can observe iron rust because there is water vapor or moisture. So from this experiment, finally we can conclude that, right? Finally we can conclude that moisture or else water vapor is necessary for rusting. Right? So moisture slash water vapor is necessary for rusting. This is the final conclusion that we can take from this experiment. Right? So let's move on with the next slide. Here the explanation is given, my dear children. See, calcium chloride crystals absorb moisture in the air in the boiling tube. Placing wax clay around the stopper makes the tube airtight. We are placing wax or clay in the stopper, right? It helps to avoid entry of air particles into the system. So it prevents the entry of moisture in air into the tube. As the air inside the tube is free from moisture, the parts of the nails inside the tube do not rust. Inside the tube, no rust. What is expected by driving the two nails into the cork in opposite directions? So I told you that when you are inserting that iron nail to the cork, we have to insert it like this, opposite directions, upside down, if like this, top part, then here the bottom, so that they have equal top and bottoms. Okay, we have to insert it like this way. So what expected by driving iron nails in the cork in opposite directions is to ensure that the pointed tip or the flat head of the nails, pointed tip or the flat heads of the nails have no effect on rusting. Means that, now somebody may say that if I am going to insert it like this, somebody may say that only the bottom part or the flat head has got haven't got a chance to get rust. Somebody may say that. It's an assumption. No, we can't assume anything when we are doing an experiment. So somebody may think flat heads are not getting rusted, but pointed head does. So therefore, to avoid that confliction, we have to insert it like this in opposite directions, right? It avoids the conflicts that's going to occur when we are going to take the necessary observations, right? Okay then. So this is the explanation for the experiment, my dear children. So we have studied two main factors essential for the rusting of iron. One thing is air and the second one is water vapor or moisture. There is another activity, right? Let's see what is that. So the third and the final activity in observing the factors necessary for the rusting of iron. Here we are going to show that oxygen gas is necessary for the process of rusting. In the earlier case, when I was doing that experiment in which I have shown you for you guys that air is necessary for rusting. If you take air particles, there are different components in air. There are several components in air, right? So we don't know what factor of air or which component of air is necessary for the process of rusting. So therefore, my dear children, we will be conducting this activity to ensure that the component called oxygen gas in air is necessary for rusting process. So let's conduct this activity and we'll get the necessary observations. So first of all, we'll get to know what are the materials we'll be needing. So you'll be needing a beaker, right? A beaker or else a water trough. It should be a large beaker or else a large water trough, right? Then boiling tubes. When you are taking boiling tubes, two identical boiling tubes, right? we have to take two identical boiling tubes, right? Remember to take two identical boiling tubes for this process. Then iron powder or iron fillings or iron powder. Then some cotton wool. These are the materials that you need. You'll be needing a large beaker or else a large water trough, some boiling tubes. Actually, you will be needing two boiling tubes, two identical. Identical means they should be equal in all aspects. Okay, so two identical boiling tubes, some iron powder or iron fillings, and some cotton wool. So these are the materials that you need. So let's see how to conduct this activity. So the method: take two test tubes. In one of them, A, trap some moist cotton wool, right? We have to trap some amount of moist cotton wool, that's it. So this is A, that contains only moist cotton wool, tube A. Okay, it's been named, but to see it more clearly, I have marked it very well. Okay, right. So in the other tube, in B, so here this is B, right? In the other tube B, trap a similar plug of moist cotton wool with some iron fillings on it. Now we have to insert some iron fillings and we have to insert the moist cotton wool into the system like this. Okay. Then take some water into a beaker and dip the two inverted test tubes A and B in water as shown in the figure. So that's why I told you that we'll be needing a larger beaker or else a water trough. So we have to put water and we have to dip the two test tube according to the given figure like this. Then observe this setup after few days. You have to observe the setup after few days. Right. Then this is the way of conducting the activity, my dear children, right? So this is the way of setting up the things or the materials, right? Now let's head on to the lab and we'll conduct our activity and we'll see what's going to happen or what kind of a change is going to occur after 2 or 3 days during this experiment. So we'll head on to the lab and we'll conduct the activity and let's see what are the changes that's going to occur. Right, my dear children. Now in the earlier activity, we discussed that air is necessary for the rusting process. You know that atmospheric air, in the earlier activity we discussed, air is necessary for the rusting process of iron. But you know that if you take air particles, the normal air particles within our atmosphere, it contains several components, right? Contains several components like oxygen, carbon dioxide, hydrogen, nitrogen, right? So like that way, there are several components contained in normal atmospheric air. So we know that air is necessary for the rusting process, but we don't know which factor of air is necessary for the rusting process. So in this activity, we'll be investigating what factor of air particles is responsible for the rusting process. So to conduct this activity, I have prepared a setup by using two stands here, a water trough, and with several boiling tubes. Okay. So first and foremost, these boiling tubes should be identical to each other in all aspects. Okay, I mean their radius should be equal to each other like this. their width should be equal to each other, and they should be in a same volume for sure. Okay, because at the end we'll be comparing, right? At the end we'll be comparing our observations, one relative to another. So in that case, to check whether we have got the necessary observations, we need to make sure that these boiling tubes are in the same dimensions, right? So now I have two boiling tubes with same dimensions. First of all, then I'm going to use some amount of iron powder or iron fillings. Iron powder or iron fillings. Right, now first of all what I'm going to do is I'm going to insert this iron powder. Right, I'm going to insert this iron powder into this test tube, my dear children. Right, so I'll use a small bit of a spoon. Then what I'm going to do is I'm going to insert this iron powder into our boiling tube like this. We need to insert the iron powder up to some extent. Right, okay, so we'll add some more iron powder into the system. Right, that's enough. So I have inserted some amount of iron powder into the first boiling tube. Then we need to place this boiling tube inverted in this water trough. We need to place it inward, right? So I can't directly keep it inverted in the trough, no, because iron powder will fall to the water trough. So to avoid falling iron powder into the water trough, I'm going to insert some amount of cotton wool. I'm going to take some amount of cotton wool and I'm going to place it within the boiling tube so that the iron powder will not fall into the water trough. So you have to take some amount of cotton wool, otherwise the iron powder will fall into the water trough. Right, that's enough. So I'll dip it in water. Right, now let's insert this thing. I'll use a glass rod to insert this firmly into the boiling tube. Right. So gradually I am inserting this thing to the boiling tube like this. Okay. Right. So this is our first setup then. Right, this is our first setup. Now I'm going to place it in here. I'm going to take the second test tube and I'm just going to take this cotton wool. Then once again, like in the previous one, I'm going to insert it in water like this. I'm going to wet it down to a certain extent. Then I'm going to insert this cotton wool to the boiling tube once again. Okay. Here we need to provide the same amount of volumes to the both boiling tubes. Remember it. That's why we are inserting the second cotton wool layer to the other boiling tube. Okay, so let's insert it. Right, so let's compare with the other one. Right, the second one, this one should go somewhat further down. Right, just slightly down, then we can continue with the next step. Yep. Okay, now these are our two boiling tubes then. Keep it in here so that you can see it very clearly. Right, our two boiling tubes. So the first boiling tube, this boiling tube contains a cotton wool and some amount of iron fillings or iron powder which is trapped inside the boiling tube. In the second one, there is only some amount of cotton wool which is same as the amount of cotton wool which I have inserted to the first one. Now what I'm going to do is I'm going to insert these two boiling tubes. Right, okay, make it into an inverted like this. Now let's insert this thing into our water trough. So remember, when you are fixing these boiling tubes inside the water trough, both the boiling tubes should be in a same level. Both of these boiling tubes should be in the same level, my dear children. Okay, both of them should be in the same level. Right, remember it. So we'll insert the second one also. So by looking at this level, I am going to insert it. Right, so I have fixed both the boiling tubes up to a same level. Right, you can observe that both the boiling tubes are in the same level right now. So now we'll need to keep this system for about few days, and we need to observe what has happened to these iron fillings. And is there any other observation within the boiling tube of this one or this one? Actually, we can get some observations only in this one because this is the one which contains iron fillings. Right? So what is the purpose of using this second boiling tube? It's like this. Now, when there is some sort of a change which is going to occur inside the first boiling tube, if some amount of gases are getting absorbed during the process of rusting, to fill that gap, some amount of water will rise through the boiling tube. But we don't know how much is the volume of it. To compare and get an idea about the volume which has risen up, we have used this second boiling tube. We can compare up to how much of a volume has the water been risen up through the boiling tube. After the rusting process starts, some amount of gases are getting absorbed by the rusting process. Means that some amount of water should rise up through the boiling tube. if I'm going to keep this setup in the same way, I won't be able to compare my observations very clearly. So what I'm going to do is, I'm going to apply some amount of a color, right? Some amount of a coloring for this water throw. So after adding coloring, you can observe the water, two levels of the water very clearly, right? So if I'm going to keep it in the same way, I won't be able to get more clear observations. So there might be a possibility where our observation would get faulty. So what I'm going to do is, I'm going to add some amount of colored water to this setup to get my observations more clearly, right? So we'll add some colored water. And gently, very gently, we'll mix it. Right. Now after the rusting process starts, you can observe the clear level of the water after rust have been created on the iron fillings. So what I'm going to do is, right now I'm going to keep this system for about 2 to 3 days. Then after that, I'm going to observe what is going to happen. Right, my dear children, now you can clearly observe what has happened to our setup. After adding colored water, we can get the necessary observations more clearly. This is our first test tube. This is our second test tube, which used to compare the volume of water. So here you can see, from this level, this is our normal water level. From this level to this much of a level, water has risen up. So from here to here, let's compare by using this boiling tube. We'll compare how much amount of water has risen up in this boiling tube. You don't need to get more accurate answer in this thing, right? Just get a rough value, right? This is to get some idea. So just get a rough value. You don't need to take more accurate values in this thing, right? So we'll compare with this thing. How much is the how much times water has risen up. So here to here, and this smaller part which the water has risen up. So we'll see how many parts are there. Here to here, 1, 2, 3, 4 and 5. Once again, about, see, 1, 2, 3, 4 and 5. Roughly there are about 5 parts in the entire volume here to here, right? From this water level to top of the boiling tube, there are like 5 parts, right? There are like 5 parts. So out of those 5 parts, 1 part is colored water. Now this is the part which water has risen up. So this part which the water has raised up is exactly 1/5 of this entire volume here to here. It's not exactly 1/5, right? But up to a certain extent, roughly, it's around 1/5, 1/5 of the total volume from here to here. So the amount of water which has risen up is about 1/5 of the total volume of the container, right? So that is our conclusion from this activity. Water has risen up about 1/5 of the entire volume in the boiling tube. Okay, about 1/5 of the entire volume we can observe colored water. That's the amount of colored water which has risen up in this activity. Now what I'm going to do is I'm going to check what has happened to iron powder or iron fillings inside the boiling tube. So now what I'm going to do is I'm going to remove this system gently, and I'm going to take out the boiling tube, and I'll keep the stand and take this petri dish. Now I'm going to take this cotton wool and let's observe what has happened with the iron powder. Okay. Right, so I can't take entire iron powder because you can remember I added some amount of water into this cotton wool. So here let's see what has happened to iron powder. Right, so iron powder has some amount of rust. Iron powder has some amount of rust. Okay, so I'll use this white color. I'll use a white color background to show it to you. I'll use a tissue paper, right? So I'll use a tissue paper. Right, now I'm going to use this iron powder and rub against with this white color paper so that you can see very clear image. Okay, so we'll see. So I have rubbed it against the paper here. You can see there is a brownish yellow color stain. There is a brownish yellow color stain. See? There is a brownish yellow color stain. Means that this iron powder has rust. Right? It has rust. That's why it contains a brown color or brownish yellow color stain, right? So what is our conclusion from this activity then? You know that 20% of our atmosphere contains oxygen. About 20%, not exactly 20%, about 20% from our atmospheric air, there is oxygen. With 1/5 of a container, or when you convert 1/5 into a percentage, that's also about 20%. It is exactly 20%, right? So the amount of colored water which has risen up in this activity is also about 1/5. So we can come into a conclusion during the process of rusting of iron powder or iron fillings in this experiment. 1/5 of some amount, 1/5 of the air has got absorbed, and we know that 1/5 of the air contains oxygen gas. So finally we can conclude from this activity, oxygen gas is getting absorbed during the process of rusting. So the component of air which is necessary for the process of rusting is oxygen gas. Right then. So we'll head on to the classroom, my dear children, and we'll write down our observations and our conclusions. Right, my dear children. So we conducted the activity and we could observe that iron fillings has got rust after 5 days and the water level has risen up to 1/5 of the container, right? To 1/5 of the container, water level has raised up. So these were the two observations that we took from the experiment. So we'll write down those two observations. Number 1, iron fillings has rust. Number 2, water level in the boiling tube moved 1/5 the total volume right? So water level in the boiling tube moved up, right? It should be up there. Moved up. Moved up 1/5 the total volume. 1/5 the total volume. That's it. So iron fillings has rust. That is our first observation. Then the second observation is water level in the boiling tube moved up 1/5 the total volume, right? About 1/5. You could see that when I'm explaining that process, I compared the level and I told you that it's about 1/5. Okay, it's about, not exactly 1/5 times, but about 1/5. So the conclusion that can be taken from this experiment. My dear children, you know that our atmosphere contains 20%, about 20%, right? There is about 20%, 20 to 21%, right? 20 to 21%, right? So our atmosphere contains 20 to 21%, let's say 20% nearly. So our atmosphere contains about 20% of oxygen gas, right? 1/5 of the container means that is also 20%. So if you want multiply 1/5 by 100, right? When you convert 1/5 into a percentage, when you multiply 1/5 by 100, you can see that here 1, here 20, right? The answer is 20%, right? So 20% of atmosphere, 20% of gases in our atmosphere contains oxygen. So we can finally conclude that during the process of rusting, oxygen gas has been, right? Oxygen gas has been used up, right? So I'll keep this thing in the same way, 20%. So 20% of air is nearly oxygen. So therefore oxygen is absorbed during the rusting of iron. Right. So this is our final conclusion from the activity. If you multiply 1 over 5 by 100, the answer is 20 or 20%. So 20% of air is nearly oxygen. So therefore we can say that oxygen is absorbed during the rusting of iron powder or iron fillings in this experiment. Right, my dear children? So we have shown that oxygen is really important for the process of rusting, right? Oxygen is the key factor which being used from atmospheric air during the process of rusting. Right then. So here the explanation is given. It can be seen that iron fillings in the tube B have undergo rusting while water has risen up to about 1/5 of its height. Okay. The percentage of oxygen in air by volume is 21%, nearly 21%. That is nearly 1/5 of air in a given space is oxygen, right? So 1/5 of the amount of air particles is oxygen, right? About 1/5, not exactly, about 1/5. If oxygen gas is used up for rusting, 1/5 of the volume of air contained in space where rusting occurs should have been spent, right? So oxygen gas should have been spent in here. For the rusting of iron fillings in tube B, oxygen gas in the air in that tube is used up, right? So we can finally conclude that the oxygen gas is being used up during the process of rusting. As 1/5 of the volume of air is oxygen, the water level rises to 1/5 the height of the test tube. From this, it is clear that oxygen gas is consumed during rusting. So it's clear to us that oxygen gas is the component which is getting absorbed during the process of rusting, right? So this is the final conclusion that we can take from the experiment. So my dear children, we discussed 3 experiments regarding the tarnishing or the rusting of iron, right? From these 3 experiments, we investigated the factors necessary for the rusting of iron. The first factor is the necessity of air. The second factor was, right? The second factor was the necessity of moisture or the necessity of water vapor. And third and finally, we showed that if you take air particles, the oxygen in air particles is being used up during the process of rusting. Right then. So it's clear to us that rusting is a chemical process or else a chemical change that's going to happen with the presence of oxygen and with the presence of moisture or water vapor, right? So this rusting process is mainly occurring due to oxygen and water vapor or moisture. So let's move on with the next slides to observe our further things with the lesson, right? So from the experiments, it can be concluded that 2 factors are essential for the rusting of iron, right? 2 main factors are essential for the rusting of iron. So what are those 2 factors, my dear children? Number one here, first factor, moisture. Moisture or else water vapor. Moisture or water vapor. This is the first one. And the second factor is air, right? Instead of air, I'll put within bracket oxygen. So these are the 2 main factors which are essential for the rusting of iron. Number 1 is moisture moisture or water vapor. The second factor is air. In air especially will be needing or for the rusting process, right? For the rusting process it will be needing oxygen gas. So these are the two main components which are essential for the rusting of iron. Right then. So in this part we'll be discussing how to protect things from rusting or metals from rusting, especially iron, right? So how to avoid the rusting of iron, we'll be discussing that part in here, right? So let's see what are the methods. Iron object rust only when they are able to come in contact with air and water. So air means especially oxygen. So when they are coming to contact with oxygen and water, right, rust is going to occur. Iron rust is going to occur. You would have seen that paints are applied on objects made of iron such as grills, gates and bridges, right? We apply paint. Why do we apply paint? Because by the application of paint we avoid the contaction of air and water with the relevant metal or the iron surface. So we can avoid the contact between the metal surface or the iron surface with these materials given in here with air and water. So by that way we can avoid the rusting of iron, right? So application of paint is a frequently used method to prevent rusting of iron. It prevents iron from coming into contact with air and water. Grease is also applied in machinery made from iron to prevent rusting. So application of a certain substance on surface of iron can be used to avoid the contaction between water, air with the relevant iron surface. So by avoiding that contaction we can avoid the process of rusting, right? If water and air is not going to contact with the relevant metal surface, then that iron surface or the metal surface will not rust. So by applying paints, by applying grease, right, we avoid the contaction between the metal surface with these two factors. Okay, right then. Next point. You have heard about the galvanized iron items. During galvanizing, now the galvanizing process. Galvanizing means here we are going to coat, right? Here we are going to apply some kind of a strong metal rather than the iron, some kind of a more reactive, more stronger metal on iron. We are applying it. So when you apply more stronger metal, that metal is subjected to rust and the iron is going to be protected from rust, right? So zinc is a more powerful metal than iron. It's more reactive than iron, right? Zinc can catch up with oxygen even more faster than normal iron. So therefore, rather than iron, zinc has a more reactivity. So due to that reactivity, when you place zinc on iron, what happens here is that when you apply, during galvanizing, zinc metal is applied on objects made of iron, right? We apply zinc metal on galvanized materials. Iron in galvanized items does not rust even if their zinc coat is scratched, exposing some of their points to air. Specialty in here is that after galvanizing, you can even scratch it, even though it's going to scratch, right? There is no iron rust. It's because that zinc attract all the oxygen and water vapor and moisture, and it protects the iron from rusting. So even though it's going to scratch and remove the zinc layer, not totally but up to a certain level, right? If totally it's been removed, then definitely it will rust. But I'm talking about like in several places, if there are several scratches, then it's okay, no problem, right? So this is called as galvanizing. Galvanizing means we are using a more stronger metal coating on iron to save the iron from rusting, right? Here the strong metal is going to sacrifice itself to protect iron, right? So therefore, galvanizing is a very good protective method to avoid rusting, right? Items such as buckets, roofing sheets, iron nails are protected by galvanizing. So roofing sheets, buckets and iron nails, right? These materials are galvanized in order to protect from rusting. So galvanizing is the best method to protect iron from rusting, right, my dear children? So here you can observe a painted gate and a galvanized bucket. Galvanizing means applying with zinc. So application of tin metal is also another method used to protect iron from rusting. Tin is a type of a metal, right? It's less strong or less reactive than iron. By applying a coating of tin, we can protect the iron from rusting. Specialty in here is that when that tin is going to scratch off, as tin has a less reactivity, both the tin and the iron is going to waste out because of rusting. Unlike in galvanizing, coating zinc is not a good method, right? It's because that it's like applying a layer of grease or oil. When the oil or the grease layer is going to fade off, the rusting will come, right? And not like galvanizing. So here, the containers of sealed food such as sardines, milk powder, though commonly called tins, are vessels made of iron, right? Sardine tins, right? Salmon tins, milk powder tins. Those things are actually not tins. Those things are made up with iron, okay? Specialty here is that in them, tin is present only as a coating. The tin metal is present only as a coating, my dear children. The metal itself is not tin. It carries a tin coating to protect it from rusting process, right? However, when scratched, tin coated vessels rust very fast. So if it is going to scratch, definitely it will rust very fast, unlike in the galvanizing process. Now in the galvanizing process, zinc is more powerful, zinc is more reactive, so zinc attracts all the oxygen and water vapor. But in here, a different case. Here we are applying a paint layer, like a paint layer, right? Paint is tin, that layer which applied is tin. So it's just a layer, that's it. It avoids the contaction of water vapor and oxygen with the iron surface. So my dear children, if you are coated with tin, when removing or upon removing tin layer, when tin layer is going to scratch, definitely it will rust fast. Okay, so these are the methods, several methods that we can do to prevent of rusting. So my dear children, we discussed about tarnishing of metals, right? And we discussed about the flames. So I hope that you got a sound knowledge about these contents. So in the next chapter, we'll discuss the further things related with our lesson.